Welcome to the lecture 5 of Unit 4 regarding Programmable Logic Array. Already we have discussed PAL and ROM. Now we will be discussing PLA, Programmable Logic Array. In this, the difference is both AND gates and OR gates are programmable. That is the difference. That means you can use the fuses for AND gate connections as well as OR gate. So this is the typical PLA architecture where there would be a single line. This line would be connected to all the terms whenever it is required. And there would be a single line for OR gate which can be connected to all the AND gates. So wherever the connection is required, you put a cross mark. That is a PLA. And what are these XOR gates? So these are the additional circuit, right? We'll be using. Why we'll be using XOR gates we'll be discussing later. So both AND gate and OR gate both are programmable. So we'll be drawing single line and we'll be connecting that line according to the requirement using a cross mark, which is nothing but a programmable. So careful investigation must be done to reduce the number of different product terms, because which reduces the number of AND gates. So how will we be doing that? We'll be discussing through an example. And you require the function in true as well as complemented format, and it should be simplified. So the thing is, one should have fewer product terms, and number of letters in each product term should also be very less. So to meet these requirements, that is to have distinct product term and fewer product terms, we'll be using a K-maps to simplify the given functions. For example, the question is given, implement the following two Boolean functions using PLA. Two functions are given, f1 is equal to sigma of 0, 1, 2, 4, f2 is equal to sigma of 0, 5, 6, 7. First you need to simplify the two functions using K-maps. So this is the simplification of f1 and this is the simplification of f2. So f1 you will be getting a bar, b bar plus a bar. So this is a function for f1 when you combine once, isn't it? When you combine once. And you need to get a complemented form also. How do you get complemented form? By combining zeros, you will be getting a complemented form. So how do you get this? So suppose, I think you know how to combine ones. Now I will be explaining how to combine zeros, right? Suppose if you consider these two zeros, what are the common things? B and C are common. So write as it is, BC. Next, these two are, you can combine these two zeros. What are the common things? A is common and C is also common. So AC is one term. Similarly, AB is one term. If you combine these two, you will be getting AB. So write as it is and I put a complement for that because we are combining zeros. Right? So you need to get the function f1 in two formats. One is uncomplemented format and a complemented format. Complemented format means you will be getting this by combining zeros. Uncomplemented format you will be getting by combining ones. Right? So like this you need to get for both f1 and f2. Now the thing is, you can use either complemented or uncomplemented functions to design a PLA. But you need to get less number of product terms. That is an important thing. Right? So how do you choose that? So these are the two formats of f1 and these are the two formats of f2. So you need to be very cautious in selecting two functions either in uncomplemented or complemented. But the thing is, you need to cover two functions with less number of product terms, less number of distinct product terms. So if I choose f1 in a complemented format, and F2 in uncomplemented format. Anyways, A, B and AC are common in these two functions. So it is better to choose these two combinations, right? And BC is the third product term, and A bar, B bar, C bar is the fourth product term. So to realize F1 and F2, you need only 4 different product terms. That is AB, AC, BC and A bar, B bar, C bar. This is what the advantage of PLA, where you can reduce the number of product terms, therefore which reduces the number of AND gates required compared to PAL and RAM. This is an advantage, right? So this is what the product sharing, right, which can be happen only in PLA. As we have discussed, PLA would be optimized, which uses less number of AND gates and OR gates. So now we can form a PLA programming table which consists of only 4 product terms, numbering those product terms, and what would be the inputs. Here C is missing, so put a dash, and A, B are uncomplemented, literal, so 1, 1. If it is complemented, you put zeros. Right? So outputs F1 in a complemented format, because we are taking F1 in complemented format, so that's why it is written in C. C means complemented, T means true form. So F2 is taken in its true form because it is not a complemented. So F1 in a complemented format requires AB, so that's why we place 1. Requires AC, requires BC, it is not required for this because A bar, B bar, C bar is missing in this. Like this, we will be forming a PLA programming table. Right? Now, final PLA relation with fuses. It is very simple, right? So once you get the product term, how to get the first product term? According to the table, A and B. Second product term, AC. Third product term, BC. So, to get A and B as a first product term, put a cross mark for B as well as A. So here it is written B and A. Similarly, the second product term is C and A, that is AC. Third is BC. Fourth is C bar, B bar, A bar. So these are the 4 product terms to which you require 4 AND gates. Right? And after this, how to get F1 and F2? For one OR gate, you require AB. That's what AB, AC and A bar, B bar, C bar. For second function, that is F1, you require this one. Right? So again, selecting the product term using OR gates, using a cross marks. And finally, we will be using XOR gate because F1 is in complemented format. So how to get that complemented format? Output of OR gate is connected to XOR gate and other input is connected to logic 1, right? So when you connect to logic 1, you will be getting F1 bar. When one of the inputs of XOR gate is connected to logic 0, the same thing is transferred. That is, F2 will be in true format. So you can realize this using XOR function, A bar B plus AB bar. Right? So to get a complemented format, you need to give logic 1 to this, right? And to get uncomplemented format, you should give logic 0 to this. Right? Actually, there should be 0 here, and here you need to give 1. Right? So this is how we will be realizing the PLA with fuses. Right? Finally, what is the conclusion? So first, if the question is given, simplify using a K-maps, 2 functions F1 and F2 in its true form and complemented form. True form you will be getting using combining ones. Complemented format you will be getting combining zeros and put a complement after simplification. Right? After this, you have to select F1 and F2 either in true or complement. There is no such rule that always one should be true and one should be complemented format. Right? So you can choose any combinations. So there exist 4 combinations, right? This and this, 2, 3, 4. So 4 combinations exist. So you can select any one of those 4 combinations, right? The thing is, it should have less number of different product terms. Very few number of product terms. So here F1 in complemented format and F2 in true format is selected, and form a table according to the table. If F1 requires AB, you put a cross mark in the format, right? Similarly, how to get F1 by combining all these product terms using OR gate. So again, put a cross mark according to the requirement. And if you want a complemented format, use an XOR gate. To one input should be logic 1. To get uncomplemented format, one input of XOR gate should be logic 0. So don't get confused with this XOR gates. So simply for true and complemented format, we'll be using XOR gates. Okay. Thank you. So this is regarding PLAs. If you are having any doubts, feel free to ask the doubts.